Example 3, again, we are going to graph another conic section without really knowing what this looks like. X squared minus y squared equals 9. If you look at this equation, this looks different from the other two that we've graphed so far because we have the subtraction in between here. So, wonder what that's going to give us. Same process as before. Let's make a table of values to figure out what this is, what this looks like. If you just cover up one of our variables for a second, okay, x squared minus y squared equals 9. I cover up this part. X squared could equal 9 if x is 3, or if x is negative 3. And if that happens, then y would need to be 0. So plus or minus 3 is 0. That works. Okay, let's see. Is there another way that we could subtract these two pieces together and get 9? Well, let's see. I know 9 plus 16 is 25. So going the other way, 25 minus 16 would give us 9. And that happens if x is positive or negative 5, and if y is positive or negative 4. This is going to give us a lot of points that we can then graph and see what we end up with. So put my graph over here and plot our points. Plus or minus 3, 0, gives us 3, 0, and negative 3, 0. Plus or minus 5 plus or minus 4 could give us 5, 4, 5, negative 4, and then negative 5, 4, negative 5, negative 4. Now, if you're not entirely sure what this looks like yet, let's try to plug in one more point and see what happens. Try to plug in one more value of x. So it kind of looks like our graph is going to go something like this. Let's try plugging 6 in for x and see what we get. We plug 6 in for x. Should have left a little more room here. So I'll do my work down here. If you plug 6 in for x, we get 36 minus y squared equals 9. To solve our equation, let's move the 36 over. Negative y squared would equal negative 27. Divide by negative 1, y squared is 27. And then square root both sides. The square root of 27 is about 5.2. Okay, so plus or minus 6 plus or minus 5.2 gives us a couple other sets of ordered pairs that we can figure out a little bit better what our graph is doing. So positive 6, 5.2, positive 6, right up here, negative 5.2. Oh, shoot, this point was wrong here. And that helps us to see a little bit better what our graph is doing. And our graph is going to keep going forever this left direction, and same thing on the right here. We'll keep going forever to the right. This is what we end up with. So this is hyperbola. And let's answer some of those same questions we did in the last example with our ellipse. If we have a hyperbola, let's think about what lines of symmetry we have. Okay, so similar to our ellipse, we have a horizontal line of symmetry because our graph is the same on the top and the bottom, both chunks here. So that horizontal line of symmetry is the line y equals 0. And we also have this vertical line of symmetry, same on the left as it is on the right. And then the domain and range. Domain and range is a little trickier for hyperbolas because if we look at our domain, our possible x values, x can't be anything in between here. If we try plugging in 0, for example, 0 minus y squared equals 9. Negative y squared can't equal 9 without us having an imaginary number. So the domain x has to be greater than 3 or equal to 3, or x would have to be less than or equal to 3. X can't be in between. Less than or equal to negative 3, sorry. Our range is a little different than our ellipse also, because our y values, well, they're going to keep going up and they're going to keep going down forever. So our range is all real numbers. All right. Again, looking back at our equation, we end up with a hyperbola if we have x squared minus y squared. Or we'll see a little bit later in our chapter, we could have y squared minus x squared. The big difference with our equation is we have to have the subtraction in between. And that gives us a hyperbola.